We will look at one ensembling algorithm for classification. We call it random forest, invented by Raymond. So random forest is a classic example of a ensemble algorithm. It uses the bagging technique of ensembling. It runs on top of basic decision trees, and it is usually proven to be more accurate than plain decision trees. Now, let us look at briefly what random forest algorithm does. Suppose you have, suppose you have original raw data like this, which is the classical problem of classification where you have labeled output. There are m rows, n variables as input and one output. What you do is, suppose you talk about creating something like an ensemble of 200 decision trees. So the random forest consisting of 200 decision trees is constructed by means of randomly sampling rows and columns from the input. So for example, when I here say that I take say something like that, and I can say I take correspondingly, let's say I take it randomly 2 rows, 4 columns, and then I append the corresponding output values. Now this becomes a smaller version of the classification problem. Likewise, we probably have another one which has similar combination. Maybe this is something like say 5 rows and 7 columns, and corresponding rows will have the corresponding 5 output values. So like that, you can have 200 such small problems, and then we probably will have one decision tree for this, one decision tree for this, rather like this we'll have 200 decision trees. So if you see what you've done is, instead of having one common decision tree for the entire data, we have created smaller subproblems. Again, as I said, choice of rows from which you pick up and the columns from which you pick up is highly random. You can do either with replacement, means once you have taken a row and a column set out here, you can put them back into this to do a redraw to get another sample. You can continue to do 200 times the draw, but depending upon whether you do with replacement or without replacement, you can get different sub samples from the original data. And then you run classification for each of them, like I said, right? Because this becomes a small classification problem by itself, and you run a classifier. So you have ultimately 200 classifiers. So what you do in order for you to get the actual result when a new input comes in is you will try to take the new input, you will find out whatever is the class corresponding to the first classifier. So you will have, say for this gives true, true, false, 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 true, like that, and then you take a majority class. Suppose true is 150 and false is 50. So you will say that the combined result is true for the new input which you have given. So So what you've done here is, instead of relying on one decision tree for the whole sample, you created classifiers for each of the 200 smaller subsamples created, smaller decision problems, each of them having its own decision tree. Then you let them run on the original the input that is coming. You find out the output class corresponding to each of the smaller tree. Then you take a majority vote among which class is the dominant class output among the 200 classifiers, and that becomes a final decision. So this is how random forest works in reality. The basic idea of random forest is you bag the results by breaking the original input into several small sub-problems, run classifiers for them, then do a majority of the class as per the output from the decision trees generated from each of the 200. You have 200, 250, 300, but usually it's a very large number of subsamples that are created. The beauty of random forest is it gives a much better accurate result because of the averaging effect across the overall input space. And another thing is it reduces the variance, which is give different inputs giving different results you try to avoid, which is one of the big problems in decision trees because it's very tightly tied to the choice of the input data on which you form your decision tree.